Welcome to Mystic Explorer. We are a new channel and want to know what you think. Let us know in the comments. Picture this, a sprawling underground complex stretching nearly 2 kilometers beneath the pyramid of Khafre at Giza. 5 identical multi-level structures with sloped roofs sit near the pyramid's base, linked by geometric pathways that form a precise, almost mathematical network. 8 towering cylindrical wells, each encircled by spiral ramps, plunge 648 meters deep into the earth, equivalent to the height of 2 Eiffel Towers stacked on top of each other. At their bottom lie 2 massive cube-shaped chambers, each 80 meters per side, large enough to house a small stadium. This isn't a fantasy. It's a real discovery, uncovered by cutting-edge radar technology. Hidden for over 4,500 years, these structures could rewrite the story of the pyramids. Welcome to the Khafre project, where ancient secrets meet modern marvels and where the past whispers truths we're only beginning to hear. The Khafre project is a groundbreaking mission to unlock the mysteries of the Pyramid of Khafre, the second largest pyramid on the Giza Plateau, dating back at least 4,500 years. This initiative stands out because it uses a non-invasive technology called synthetic aperture radar, also known as SAR, to peer beneath the pyramid's surface, revealing hidden structures without disturbing a single stone. The project is led by 2 remarkable researchers, Filippo Biondi, a radar and remote sensing expert from the University of Strathclyde in Scotland, and Corrado Malanga, a scholar from the University of Pisa in Italy. Together, they've combined their expertise to push the boundaries of archaeological discovery. Filippo Biondi is a name well known in the field of radar technology. He's spent years developing advanced SAR techniques, focusing on how radar can detect minute vibrations and map hidden structures. His work isn't just theoretical, he's applied it to real-world scenarios, from monitoring infrastructure stability to exploring archaeological sites. Biondi's passion for using technology to uncover the unseen has made him a pioneer in non-invasive exploration, and his contributions to the Khafre project are built on a solid foundation of prior research. Corrado Malanga, on the other hand, brings a different perspective to the table. A scholar with a deep interest in ancient civilizations, Malanga has spent decades studying the cultural and symbolic significance of ancient monuments. He's known for his unconventional approach, often exploring alternative theories about the origins and purposes of structures like the pyramids. While some of his past work has ventured into controversial topics like UFOs and alien abductions, his focus on the pyramids centers on their potential as more than just tombs, a perspective that aligns with the Khafre project's findings. Before the Khafre project, both researchers had already made significant contributions to their fields, which lends credibility to their current work. Filippo Biondi has a robust portfolio of peer-reviewed papers on radar technology. One notable paper, published in 2022 in the journal Remote Sensing, is titled "Synthetic Aperture Radar Doppler Tomography Reveals Details of Undiscovered High-Resolution Internal Structure of the Great Pyramid of Giza." Quite the mouthful, isn't it? In this study, Biondi explored how SAR could detect micro-movements caused by seismic waves, allowing for high-resolution 3-dimensional imaging of the Great Pyramid's interior. He demonstrated that SAR could reveal hidden chambers and passageways, a technique he later applied to the Khafre pyramid. Another of Biondi's earlier works focused on using SAR to monitor the vibrational modes of ships, showing how the technology could be adapted for various applications, from maritime surveillance to archaeological exploration. His expertise in turning radar signals into detailed maps of hidden structures made him the perfect fit for the Khafre project. Corrado Malanga's previous publications are more eclectic but equally relevant. He's written extensively on the symbolic meanings of ancient sites, often questioning mainstream interpretations. One of his notable works, published before the Khafre project, examined the cultural significance of ancient Egyptian architecture, suggesting that structures like the pyramids might have served multiple purposes: ritualistic, astronomical, or even technological. Malanga's research often challenges the traditional narrative, proposing that ancient civilizations might have possessed knowledge we've yet to fully understand. While some of his ideas, like those on extraterrestrial influences, have been met with skepticism, his focus on alternative interpretations of ancient monuments adds a thought-provoking layer to the Khafre project's findings. Let's travel back to 2570 BC during Egypt's Fourth Dynasty, a time when the Giza Plateau was a bustling hub of construction and innovation. The mainstream theory suggests that Pharaoh Khafre, son of Khufu, built the Pyramid of Khafre as his tomb, a towering monument standing 471 feet tall. Its limestone casing, which once gleamed like a beacon across the desert, has mostly weathered away, though some stones still cling to the top, offering a glimpse of its former glory. Nearby stands the Great Sphinx, its enigmatic face possibly mirroring Khafre himself, a silent guardian of the plateau. But this traditional view, that the pyramid was solely a tomb, has been debated for centuries. Some researchers and alternative thinkers argue it might have served other purposes, perhaps tied to rituals, astronomy, or even advanced technology. For a long time, we've only known of one burial chamber inside the pyramid, leaving many to wonder what else lies hidden within or beneath this ancient structure. The Khafre project is finally providing answers, but those answers are raising even more questions. So how do you explore a pyramid without digging or risking damage to its ancient stones? The answer lies in synthetic aperture radar, or SR, a technology that's revolutionizing archaeology. SR works by sending radar waves from satellites or planes down to the Earth. These waves can see micro-vibrations in materials like stone, sand, and soil, bouncing back when they encounter something solid or hollow. By measuring the time it takes for the waves to return with the satellite in many different positions, scientists can create a detailed three-dimensional map of what's below the surface. It's like giving the pyramid an X-ray, but with far greater precision. Filippo Biondi and Corrado Malanga used SAR data from platforms like Capella Space and Umbra, which were originally designed for tasks like monitoring environmental changes or tracking natural disasters. These platforms provide high-resolution radar images capable of detecting even the smallest changes in density or structure. Biondi's proprietary software takes this a step further by transforming radar signals into phononic information, essentially turning vibrations into sound-like data that can reveal millimetric movements. They claim allows the team to detect not just large voids, but also tiny cracks or shifts within the pyramid's structure. What makes SAR so groundbreaking for archaeology is its non-invasive nature. Traditional methods often involve excavation, which can damage priceless historical sites. SAR, on the other hand, lets researchers explore without touching a thing, preserving the pyramid for future generations. It's a perfect blend of modern technology and respect for the past, and the results it's yielding in the Khafre project are nothing short of astonishing. Let's dive deeper into what Biondi and Malanga discovered with their SAR scans. Inside the pyramid of Khafre, they found hidden rooms and corridors both above and below the known burial chamber, suggesting a more complex internal layout than previously thought. These internal spaces vary in size. Some are small, perhaps only a few meters across, while others are larger, potentially spanning 10 to 15 meters in length. The corridors connecting them are narrow, winding through the pyramid's core, hinting at a design that might have served a specific purpose beyond mere burial. But the most shocking discovery lies beneath the pyramid, a subterranean system stretching nearly 2 kilometers under the Khafre pyramid, connecting to the broader Giza complex. Near the pyramid's base, the team identified 5 identical structures, each with 5 levels and sloped roofs, resembling miniature pyramids or stepped platforms. These structures are interconnected by geometric pathways, forming a network that appears almost too precise to be random. The pathways are straight and angular, suggesting careful planning and engineering. Below these structures, the scans revealed 8 vertical wells, hollow cylinders surrounded by spiral ramps that descend 648 meters underground. That's over 2,100 feet, deeper than many modern skyscrapers are tall. These wells are evenly spaced and uniform in design, each with a diameter of about 10 meters, their spiral pathways winding down like a staircase into the earth. At the bottom of these wells, the team found 2 massive cube-shaped chambers, each measuring 80 meters per side. To put that in perspective, each cube is large enough to fit a small sports arena or a multi-story building. These chambers are perfectly symmetrical, their walls appearing smooth and deliberate in the radar data, indicating they were man-made rather than natural formations. This underground network is a marvel of ancient engineering, locked beneath the desert for millennia. The scale and precision of these structures raise big questions. Who built them? How? And most importantly, why? The Khafre project's findings are challenging everything we thought we knew about the Giza Plateau. Biondi and Malanga have documented their findings in 2 major publications. The first is their book, Kunum Kufu Chiope, The End of a Mystery, which provides a detailed narrative of their journey, from the initial SAR scans to the interpretation of the data. The second is a 2024 paper by Biondi titled Synthetic Aperture Radar Doppler Tomography, reveals details of undiscovered high-resolution internal structure of the Great Pyramid of Giza, which built on his earlier 2022 work exploring SAR's ability to detect hidden voids in ancient structures. That 2022 paper, also published in Remote Sensing, focused on the Great Pyramid and laid the groundwork for the Khafre project by demonstrating how SAR could map internal features with unprecedented detail. Malanga's prior publications, including studies on the symbolic meanings of ancient sites, add depth to their analysis, encouraging readers to consider alternative interpretations of the pyramid's purpose.
Check 1, check.
The full scope of their discovery was revealed to the world at a press conference in Italy on March 15, 2025, just a week before today, March 22, 2025. Archaeologists and scientists were stunned by the findings. One expert called SAR the future of exploration, praising its ability to uncover hidden structures without invasive methods. Others, however, urged caution, noting that while the radar data is compelling, physical excavation would be needed to confirm the findings because, as of now, SR is only used for discoveries, just under the surface, a process that faces significant hurdles due to Egypt's strict regulations on archaeological digs. If you made it this far, thank you. Please subscribe to this channel and help us grow. Why does this discovery matter? For one, it challenges the traditional narrative that the pyramids were solely tombs for pharaohs. The 5 multi-level structures, the deep cylindrical wells and the massive cube chambers suggest a purpose we're only beginning to understand. Were these spaces used for rituals, perhaps tied to ancient Egyptian beliefs about the afterlife? Could they have been storage facilities for sacred artifacts or resources? Or do they point to a more advanced technological function, as some alternative theories propose? The complexity of the underground network also raises questions about the engineering capabilities of ancient Egypt. Building such a system, especially the 648-meter deep wells, would have required incredible skill and knowledge. How did they achieve this with the tools we believe they had, like bronze chisels and wooden sledges? The precision of the geometric pathways and the symmetry of the cube chambers suggest a level of planning and mathematical understanding that goes beyond what we've traditionally attributed to the 4th dynasty. The Khafre project's findings have reignited interest in alternative theories about the Giza Plateau, many of which have been proposed by notable figures over the years. Let's explore some of these ideas, which suggest that the pyramids and the underground areas beneath them might have served purposes far beyond burial. Christopher Dunn, an engineer and author, proposed in his 1998 book, The Giza Power Plant Technologies of Ancient Egypt, that the Great Pyramid was a machine designed to convert seismic vibrations into usable energy. Dunn argued that the pyramid's internal chambers and shafts were tuned to resonate with the Earth's natural frequencies, generating power through acoustic forces. He later expanded on this in a 2024 follow-up book, connecting his theory to Nikola Tesla's research on wireless energy transmission. Dunn's ideas, while controversial, gain new relevance with the discovery of the Khafre project's underground structures. Could the cylindrical wells have acted as conduits for energy or sound waves, as Dunn might suggest? Nikola Tesla himself, the pioneering inventor known for his work on electricity and wireless energy, speculated that the pyramids might have been used to harness Earth's natural energy. Tesla believed that ancient structures could tap into the planet's electromagnetic fields, a concept that inspired his experiments with scalar waves and wireless power. While Tesla never visited Egypt, his theories about energy transmission resonate with the Khafre project's findings, particularly the massive cube chambers that some speculate could have served as energy storage units. André, though less known, has also contributed to alternative theories about the Giza Plateau. Cooling, a researcher of ancient technologies, proposed that the pyramids were part of a larger network of structures designed to channel and amplify energy, possibly for communication or environmental control. He suggested that underground chambers beneath the pyramids might have housed mechanisms to facilitate this process, a hypothesis that aligns with the Khafre project's discovery of a sprawling subterranean system. Edgar Cayce, a 20th century psychic often called the Sleeping Prophet, offered a different perspective. Cayce claimed that the Giza Plateau was home to a hidden hall of records, a subterranean library containing the history of a lost civilization, possibly Atlantis. He predicted that this hall would be found beneath the Sphinx, connected to the pyramids through underground tunnels. While Cayce's predictions remain unproven, the Khafre project's findings of a 2-kilometer underground network fuel speculation that such a haul might exist, waiting to be uncovered. These alternative theories, while not accepted by mainstream Egyptology, highlight the enduring mystery of the Giza Plateau. The Khafre project's discoveries provide fresh fodder for these ideas, encouraging us to question what we think we know about ancient Egypt. The Khafre project is just the beginning. SAR technology could be used to explore other ancient sites, Saqqara, Mesopotamia, or even submerged ruins in the ocean, all without causing harm. The non-invasive nature of this method ensures that we can preserve these treasures while uncovering their secrets, a balance that's crucial in a world where cultural heritage faces threats from conflict, climate change, and time itself. But the journey doesn't end here. The Khafre project team has expressed interest in excavating the site to confirm their findings, though Egypt's strict regulations on archaeological digs pose a challenge. If they succeed, we might finally get a closer look at those underground chambers and wells, potentially unlocking answers to questions that have lingered for millennia. Want to dive deeper into this mystery? Check out Biondi and Malanga's book and paper, linked below, for a detailed look at their research. Subscribe for more updates on the intersection of history and technology. What do you think lies beneath the Giza Plateau? Are we on the brink of uncovering lost technologies, or is there another explanation waiting to be found? If you made it this far, thank you. Please like, comment, and subscribe to this channel so that we can make even better videos in the future.